Given to you are two functions, a function f and a g, defined on the same domain 0, 1. Function f of x is defined in this particular fashion, whereas for function g, bounds are given to you. And they are interested in knowing what is limit x goes to 0 f of x times g of x. What do we think? G of x is not explicitly given to you, just the bounds are given. Just two functions are given between which your g of x is sandwiched. So we try recalling our sandwich theorem. What a sandwich theorem says, do you know that? That if you have a function phi of x that is sandwiched between two functions, let's call it alpha x and beta x. And if you know that limit x goes to, let's write 0, alpha x is same as limit x goes to 0, beta x is some, let's say, gamma. Then from sandwich theorem we can conclude even limit x goes to 0, phi x, the function which is sandwiched between the two, the limit for that also should be gamma. So we try exploiting this particular theorem now. But now if we look at the function f of x is not explicitly given in terms of x, it is in terms of n. They only give you that x is lying in this interval, then my f of x is this value. So first of all, I need to get f of x in terms of x. So let's do that. So what is given to you is f of x is under root n. But where is my x now? My x is lying between 1 over n plus 1 n. So now here we have to solve this a little bit more. So let's take the reciprocals. Okay, everyone is positive here. So if you take the reciprocal, you get this. This lies between this and n plus 1. We have to solve for n. You see, n is sitting here for that. So this is quite clear that n is lesser than 1 by x. Let's make things clear here as well. From here, if I subtract a 1 on both sides, I get that n is greater than 1 by x minus 1. So now I get, right, that from this inequality and this inequality, I get bounds for n now. N lies between 1 over x minus 1 and 1 over x. Now, everyone is positive. You can take an under root on everyone. So still the inequality is valid. Okay, now this is your function f of x, right? So you got the bounds for even f of x. So even for the product, isn't it? Now if I write the product f of x g of x, okay, so I can write, okay, so for f of x I write this value, okay, I write under root 1 by x. For g of x I write this value, that's the bound, 2 under root x, right? And on the left hand side, what do I do? Yes, this number, right? F of x is bounded below by root 1 over x minus 1. And for g of x, this is the lower bound. So if you want, you can try writing the whole thing. So what next? You have to take limit x goes to 0 in all of them. Okay, so let's try looking at this. What is limit x goes to 0? So here you can clearly see x is set cancelled, and if you take limit x goes to 0, okay, it's just 2, right? So this value is 2. Okay, so you get this side limit to be 2. Done. Okay, now if you get even this limit to be 2, limit x goes to 0, this whole thing, if you get to be 2, then don't you think that this will be 2? The only thing you have to check whether this is 2 or not. If it is, the answer is C. If it is not, you have to use some other strategy. You're not sure what is going to happen. Okay, so let's be hopeful. Let's come here. So we want to find out limit x goes to 0 under root. Let's write simplified version of that. 1 minus x over x times integral. Let's write the complete thing. What is this form? If you plug in x is 0, what do you get? This is infinity, right? This whole thing will be infinity. This whole thing will be 0 to 0. That would be 0. So infinity times 0. If I at all want to use L'Hopital's rule, then I want 0 by 0 form. So let's bring it in 0 by 0 form. What did I do? I bought this in the denominator, the reciprocal of that in the denominator, right? Okay, now I can use my L'Hopital's rule. If I differentiate the numerator separately and denominator separately. So what is the derivative of the numerator? Instead of t, I'm going to write a x. Derivative of x, that is 1. Minus, next instead of t you are going to write as x square, 1 minus x square and upon x square. Then derivative of x square, that's 2x. Similarly, you have to separately find derivative of the denominator, which would be 1 over 2 under root. You know how to find the derivative, so reciprocal of that. And then using chain rule, denominator, derivative of numerator, minus numerator, derivative of denominator, denominator square. That's all. Okay. Now the only thing is left is simplifying. Okay, and you are done. Okay, what should I do now? Shall I take, okay, let's take under root 1 minus x over x outside. Okay, I am left with 1 minus, okay, and what else? Under root 1 minus 1 plus x. Okay, 1 minus x you have already out. So you had, and 1 x is remaining here. Okay, you have taken this out. Times 2x, that's okay. What is left? 1 minus x over x into, okay, this guy gets cancelled. You are just left with 1 over 1 minus x square. Okay, now you see what? Clearly these guys gets cancelled. Okay, now bring everything on the top. So you get limit x goes to 0 to 1 minus x square on the top. And let's simplify. What is this? 1 minus under root 1 plus x into 2 root x. Okay, this gets cancelled. Okay, this and this root x. Okay, now put the limit. X is 0. Okay, of course 0 from positive side. So 0, if you put, what do you get? This is 0, this is 2, this is 1, and you get a 2 basically. So you are done, right? Sandwich theorem. Even this goes to 2. Okay, limit x goes to 0, even this goes to 2. That means limit x goes to 0, f of x gx or to 2, and that is your answer. C. Question was not difficult. Finding the limit using L'Hopital's rule, it is a very simple thing to do. I will see you with another question soon.